Okay, I'm going to just go over a few questions from the worksheet that was on area and population density. But first, I just want to go over the question on number 1, just to go over the finding the area of a shaded region. So I do have the answer key posted to this, but just in case you're having a little trouble. So if we want to find the area of just the shaded region, our first step is we're going to find the area of the square. Whoops, hang on one second. Make sure that I can write. Okay, so first we're going to find the area of the square, okay? And then from that, we're going to subtract the area of the circle, okay? So the area of the square is length times width, and that's 14 times 14, which is 196. Okay, so that's the area of the, if we wanted the entire thing. But we don't want the entire thing, we just want the part that's out, that's not the circle. So, let me just erase this. Now let's get the area of the circle. So, that formula is pi r squared, okay? Now, looking at the diagram, since it's a square, all the sides are equal. Now, if I were to draw the diameter of this circle, it's going to be equal in length to one of the sides of the square. So it's also going to be 14 centimeters. So if the diameter is 14, the radius is half of that, so the radius is 7, okay? So that's going to then be, when I go back to my formula, just going to plug in pi times 7 squared, and that gives us 49 pi. You can leave it like that, unless the question asks you to round to a specific decimal point. I would leave it in terms of pi. So for this one, we're going to take then the area of the square. Let me just change my color. Okay, so the area of the square is 196, and subtract the area of the circle. Okay, so if I didn't, in this particular example, I didn't say anything about rounding, so in that case, I would leave the answer like this. Let's say I'd asked you, though, to round your answer to the nearest tenth, then you would just plug this into your calculator and you would get 42.1 centimeters squared. The units for area are always going to be whatever the units are squared. And if you're not given the units, then I would just literally write units squared. Okay? All right, I'm going to skip over the second question in the do now because I just want to get to the questions involving the having to draw the box around to do the area. So I'm going to go over this little box on the bottom before I do the question above it. So if you're given a figure where you can't clearly count the spaces to do, you know, in this case, 1/2 base times height, what you want to do is draw a rectangle going around it. So draw a rectangle around the given triangle. Calculate the area of, the rectangle. Whoops. Then calculate the total area of all the small triangles. And subtract. So what I mean when I say small triangles, so over here we have the rectangle that's been drawn around the triangle that we're looking for. So I would label this triangle 1, triangle 2, and triangle 3. Okay, so I would first get the area of the entire rectangle, which is length times width. So that's going to be 3 and 4, so 3 times 4, which gives us 12, okay? And now I'm going to find the area of each one of the triangles. Okay, so all the formula for area of a triangle is 1/2 base times height. So for the first one, our base is 1 and our height is 2. It actually doesn't matter like which one you call the base or which one you call the height. So 1/2 times 1 times 2 is just going to be 1. For triangle 2, our base and our height are both 3. So 1/2 3 times 3 is 4.5. And for triangle 3, our base and height are 1 and 4. And that's going to equal 2. Okay? So then if we were to add up, oh, whoops, I didn't mean to do that. Hang on. Let's bring that back to 1. Okay. If we were to add up the areas of the 3 triangles, we would get 7.5. Okay? If we were to add that up. So what we're going to do is take that 7.5 and subtract it from the 12. Okay? And that would give us then 4.5 units squared. Okay? So that's how you do a problem that looks like that. Just because we can't actually count the boxes to do the 1/2 base times height. Okay, so both questions, and again, I have the answer key up. So all these questions on these 2 pages, so example 1, example 2, and example 3 are all the same way. Now, example 3 has one teeny part of it that's a little different. There's actually also going to be a rectangle you need to subtract off. Oh, sorry. But why is this not? Okay. So if you look here, when we draw the... let me pick a color. Oh, I'll just do black. Okay. When we draw the rectangle going around it... Oh, why is this... That's not what I wanted. Okay, hang on one second. Background color... Okay, so if we're drawing going around it like this, we get this sort of like weird boomerang shape over here on the right. So we have to separate that so that we have 2 triangles and this little baby rectangle. So when you do the numbers here, this is, and it doesn't matter really which one you label as 1, 2, 3, or 4. So there's triangle 1, triangle 2. Oh, do I have to change the background color every time? I guess I do. Okay. This will be our little baby rectangle. We'll just call that 3, 4, and 5. And you'll just find the area of all of those outside pieces and subtract it from the area of the rectangle. Okay? And again, I have that up on the answer key, but if that's still confusing to you, just let me know and then I can go over them more in depth. So now on this page, we're talking about population density. So population density is just saying pretty much how dense or how compact is a certain area. So for example, New York City is going to have a higher population density than, let's say, Wyoming. Okay, because in Wyoming, there is fewer people per square mile. In New York, we have a lot of people per square mile. So that's the idea of population density. So looking at example 1, and this is right here is the formula for population density. Now, you don't get that formula on your formula sheet for any exam, so that one you do have to know. All of your area formulas you do get, though. Okay, and I'll post actually what the formula sheet looks like that you'll have access to. Okay, so let's take a look at example 1. So Weinsteinville has a population of 5,500. while town Resville has a population of 4,240. If Weinsteinville is 100 square miles and Resville is only 80 square miles, which town has the higher population density? Okay, so let's set this guy up. All right, so here is Weinstein. Hang on. Still getting used to doing this. Okay. All right, so here is Weinstein. And here is Res. Okay, so to get the population density, we are doing population over area. So the population of Weinsteinville is 5,500, and my area is 100 square miles. So 5,500 divided by 100 is 55. So that means there are 55 people per square mile. Okay, so that's what's going on in Weinsteinville. Now let's check out Resville. So Resville has a population of 4,240, and the area of Resville is 80 square miles. Okay, so when we divide that, we get 53. So that means that there are 53 people per square mile. Okay, so that means that, so which town has the higher population density? That would be my town, Weinsteinville, has more people per square mile. Okay, so that means it's denser, it's more compact. All right. Okay. All of the examples are pretty much like this, but let me go over example 2 because there's one sort of extra aspect to number 2. You're going to actually have to also find the area that was not given to you in this one. All right, so during an experiment, the same type of bacteria is grown in 2 circular petri dishes. Petri dish A has a diameter of 5 centimeters and approximately 50,000 bacteria after 1 hour. Petri dish B has a diameter of 6 centimeters and has approximately 80,000 bacteria after 1 hour. Determine and state which petri dish has the greater population density of bacteria at the end of the first hour. Okay, so we are going to, just like we did in the previous problem, we're going to do each petri dish, or each one on its own. Separately, I mean. Okay, so let's start with petri dish A. All right. Okay. Actually, wait one second. Okay, so here is A. Okay, so to get the population density, we are doing population over area. So the population of petri dish A is 50,000. Now, they haven't given us the area, but what they did tell us, what we can see is that it's a circle, and they've given us that the diameter is 5 centimeters. So if the diameter is 5 centimeters, that means the radius is 2.5 centimeters. Okay, so we're going to use our area of a circle formula, which is pi r squared. And we're doing pi times 2.5 squared. So 2.5 squared is 6.25. And we're just going to attach the pi. I don't want you to round this number to plug it in because we never want to round until we get to the very end of a problem. So we're going to leave it like this with the pi and use that to plug it into the problem. Now, when I put the area here, now when you're typing it in your calculator, this is super important. You need to put the denominator in parentheses. The reason being is that you're putting the pi next to the number. So it's not just that you're dividing by 6.25, you're dividing by 6.25 pi. And the calculator is going to read it incorrectly if you don't put the parentheses around it. So please remember to do that. So when we do that, we get if I round it, 2,546 bacteria per centimeter squared. Okay, so that is for Petri dish A. All right, now we're just going to do the exact same thing for Petri dish B, and I'm actually going to write it over here just because I'm running out of space. Okay, so for Petri dish B, I'm still on this problem, just doing it over here. We're doing, again, population over area. So the population of Petri dish B is 80,000. And now they've told us here that the diameter is 6, which means that our radius is 3. So to get the area, we're just doing pi r squared, so pi times 3 squared, which is 9 squared. I'm sorry, which is 9. So our area is 9 pi. So when then we take this and we plug it in back into our formula, again, put parentheses around the 9 pi before typing it into your calculator, and we get 2,829 bacteria per square centimeter. Okay, so looking at our numbers for who has the greater population density, that would be Petri dish B. Okay, because his number is higher than this number. Okay, all right. So examples 3 and 4, again, I have on the answer key, but if you need me to go over those specifically, we can do a Google Meet or a Zoom class. I'm going to be posting a video in a minute that goes over some of the homework problems. Okay? All right. Thanks, guys.